Good morning, I'm Dr. Huang. Today, I'm going to teach you a method to determine the order of the reaction and the value of the rate constant if we're given the concentrations of a product at different times. As we know, to determine the order of the reaction and the value of the rate constant, we have to know the concentrations of the reactant at different times. Therefore, we have to find a way to convert the concentrations of a product into the concentrations of the reactant at different times. We have to use stoichiometry to do the calculation. As we know, at T equal to infinity, all the reactant will be converted into the product. Therefore, from the infinity concentration of the product, we can calculate the initial concentration of the reactant. Since we know the initial concentration of the product is 0, therefore the change from T equal to 0 to T equal to infinity is equal to this number. From the balanced chemical equation, we can know the ratio between the change of the product and the change of the reactant. As we know, at T equal to infinity, the concentration of A will be 0. Therefore, the initial concentration of A is equal to 0.624 molarity. Well, now let me show you how to calculate the concentration of A at T equal to 10 minutes. Remember, the balanced chemical equation tells us the ratio of the change of B and the change of A. Since we know the initial concentration of A, we know the change of A, we can calculate the concentration of A at T equal to 10 minutes. Well, I think you probably need another example to show this calculation. Let me pick T equal to 30 minutes as an example. At T equal to 30 minutes, the concentration of B is equal to 0.200 molarity. We can use the change of B to calculate the change of A from the balanced chemical equation. Then we use the change of A and the initial concentration of A to calculate the concentration of A at T equal to 30 minutes. With the same method, we can calculate the concentration of A at any time here. Then, after we calculate the concentrations of A at any time here, we can use the plotting method to check the order of the reaction. These are the results. To run the zeroth order test, we have to plot the concentration of A as a function of time. Remember, do not include the infinity into your plot because there's no way to show the point of infinity. To run the first order test, we have to plot the natural log, the concentration of A as a function of time. To run the second order test, we have to use the reciprocal of the concentration of A as the y-axis and the time as the x-axis. As we plot, we will get an R-square value. For the zeroth order test, the R-square value is equal to 0.9127. For the first order test, the R-square value is equal to 0.9999. For the second order test, the R-square value is equal to 0.9115. Remember, for a perfect linear line, the R-square value is equal to 1. The closer the R-square value to 1, the more linear it is. Therefore, the reaction is first order reaction. From the slope, we can get the rate constant K of the first order reaction. It is equal to negative slope. That means K is equal to 0.0338. The unit is 1/2. We're done.